Hello, this is Preetam Biswas. I've completed the first task, prediction using supervised machine learning for the GRIP internship by the Sparks Foundation. In this task, our motivation is to predict the percentage score of a student based on the number of study hours. This is a simple linear regression task as it involves just two variables, that is, hours and scores. Firstly, I've imported the required libraries, which are pandas, which is used for the data analysis, NumPy for manipulating the array objects, and matplotlib for plotting our required plots. Next, I've imported the dataset from the source in CSV file format and extracted some observations of the data using the head function. In the third step, there are some information about the data, which we can see that there are 25 entries and two columns where hours is the float type variable and scores is the integer type. And here is some statistical properties of the data, which are mean, standard deviation, minimum value, the percentiles, and the maximum value. Then I've shown the shape or the dimension of the data, that is the rows and the columns of the data, which are 25 observations and two variables. Next, I've checked for the null value or the missing values in the data, which are in this case none, so nothing to do after that. Then I've moved on to printing the scatter plot to analyze the relationship between the two variables using the plot function. And here we can see that there is a linear relationship between the two variables, the percentage score and the hours studied by a student. Next, there are some pre-processing done on the data, which is reshaping of the data into a single vector. The hours values are stored in vector x and the scores in vector y. In order to work on that, we would need these two vectors. Next, we have to select a model to analyze and measure the new vectors, for which I've used the sk.model selection and imported the trend test split library. And in order to train our data and test it on a randomly selected sample, here I've given the test size as 0.2, which means that 20% of the data will be used for testing. So as we have 25 rows of observations, which means 5 rows will be used for the testing part. Next, I've fitted the linear regression line to the training dataset, which is also a randomly selected data of 20 observations, as the remaining 5 observations will be used for testing part. Next, I fitted the model using the model.fit and predicted the y value, which is the percentage score of a student based on the study hours. Next, I found the equation of the regression line using the y-intercept, that is the scores intercept, and the coefficient of the hours. And for the fitted regression line, the values are shown here. Then we have the plotting of the regression line, and using the matplotlib library it is done, and we can see that all the data points are closer to the fitted regression line, and the line seems to be linear, so we can comment that there is a linear relationship between the variables. That is, if the number of study hours increases, then the scores increase in somewhat linearly. Then I've used the model.predict to predict the scores and store it in a variable, and we've printed it. As these observations are for the testing dataset, so we have these 5 randomly selected values by our seed generated. Next, the model.score gives the accuracy of the fitted model, which in this case is 94.5%, which is really great. And there is a sample prediction, which is for 5 hours. And we can see that if a student studies for 5 hours per day, then he or she can score 51.5% as the model predicted. Next, we have compared the actual and the predicted values based on the testing dataset which was randomly selected. So there are the actual and the predicted values, and we can see that the predicted values have come out with a slight difference from the actual values. So our model is not perfect, hence we would have some absolute error, which we will see later. Next, I have plotted a bar diagram to showcase the actual and the predicted scores of the students. Then, for the goodness of fit, I have shown the error values, which are not quite very high, so it shows that it's a moderately good fit, not the perfect one, but it is a quite good fit. And the R squared value is 94.5%. So here in a model, we know that the R squared value for a testing dataset gives the goodness of fit. In our model, the testing dataset has R squared value of 94.5%, which is really good. So 95% of the observed variation in percentage score of the student can be explained by the study hours. Lastly, a question was asked to predict the percentage score of a student who studies for 9.25 hours per day. And we found out using the model.predict function that it is about 93.7%. So we can conclude that here in this machine learning task, we have fitted a suitable linear regression model involving 2 variables. And for the goodness of fit, we found that our model explains 94.5% of the variation in scores of the student based on the study hours. Lastly, we conclude from the fitted model that a student studying for 9.25 hours per day is expected to score 93.69%. Thank you.